All right, good morning. This is part 2. We're going to show some examples of combining like terms. So here in this first example here, we have 2x to the power 8 and 4x to the power 8. We want to add them together. So let's first make sure that they are like terms. The first thing that I noticed here is that we have the variables are x's. So good. Step 1, complete. We have the same variables. Next, we have to look at the exponents. So both exponents are 8. Good, sweet. We met both the criteria that we need. So all we are going to do is we are going to keep the variable and the exponent the same. We're just going to add the coefficients, the numbers in front. So in front, I have 2 plus 4. So this is going to become our new coefficient. So 2 plus 4, you can use your fingers there and go ahead and count 1, 2, 3, 4, 5, 6. So 6 x to the power 8. That is our answer. Looking at another one, this one is a subtraction example. Again, let's just double check our variables. We have an x, we have an x. Okay, variables are the same. Good start. Let's look at the exponents. Exponents 4 and 4. Sweet, exponents are the same as well. So let's go ahead and take those coefficients, and we want to subtract them this time. So 5 minus 2. And that's going to go in front of x to the power 4. That's not changing at all. The 4 is kind of like not a number. It's an exponent, really. So it has nothing to do with these coefficients here. So 5 minus 2, that is 3. So we get 3x to the power 4. That is our answer. Now, this gets a little bit more difficult when we have multiple things going on here. Like, look at this. We have an a and an a. We have this b just kind of chilling here. And then for some of you, you're probably looking and saying, hey, there's no exponents here. Well, here's a good rule about exponents, is that when there's no exponent written, the exponent is 1. So there's kind of an invisible 1 here. So these all have the same exponents. But if you look, this b, there's no other b here. So let's kind of just leave that alone for a second. And let's look at combining these two here. So we have 2a minus 4a plus 3b. Yes, I just rewrote the equation like that. And no, it's not illegal. We could rewrite equations kind of how we want to, as long as we're obeying the math rules, and they won't get us. So we have a and a, right? A to the power 1. So we have 2 minus 4, a. And then there's that 3b tacked on at the end there. Okay, so 2 minus 4. Ooh, some of you are probably tempted to think 2 here. But remember, 2 minus 4 is actually going to be negative 2. So we have negative 2a and then plus 3b. Kind of tricky. A little tricky. Let's look at our last example here. We have 3x squared, so 3x to the power 2, plus 4x minus x. Couple of small things here. You notice there's no coefficient in front of this x here, so there's actually another invisible 1. That goes right there. So I'm going to write that in because it might help us. Let's look at all the variables. We have x, x, x. Beautiful. Now let's look at the exponents. We have a 2. And then we actually, like I said before, if there's no exponents written, the exponent's a 1. So there's a 1 here and a 1 here. I can't combine those. Well, I can't combine the 1s and the 2s, right? They have the same variables, so we met that criteria, but they don't all have the same exponents. So this 3x squared can't combine with anything else. Then we have the 4 minus 1, so I'm going to go ahead and do plus, and then 4 minus 1, right? X to the power 1. So I can go ahead, I can combine those, right? The 3x squared will stay the same. 4 minus 1 is 3, so plus 3x to the power 1. And you could double check that this is in standard form, right? Both of these last two, it's in alphabetical orders. This is A followed by B, and these are all X's, so there's no other order. And then the variables decrease, right? So the exponents decrease, so 2 and then 1. And that's it. That is how we combine like terms. Go ahead and work on the practice that summarizes all this. Best of luck, and let me know if you have any questions.